Hello, this is Mr. Montgomery. This video is geared toward my Physical Science 2 lab students. We're going to look at some example problems with some conversions between grams and moles, number of atoms. We're also going to look at some examples of talking about how to find the volume of a cylinder and the radius of a cylinder. I put a link to these examples down in the description below. So these examples are going to help you with your atomic radius lab. One of the things you're going to do in that lab is, after you've watched that other video that I'll link in this description as well, that you need to calculate the volume of a cylinder. Well, if density equals mass divided by volume, then you're going to multiply both sides of this equation by volume to get it to cancel out here. So now volume times the density would equal the mass. Then you want to divide both sides by the density, so that in the end you leave the volume all by itself. So volume must be the mass divided by the density. You're going to have the mass of the cylinder of the copper wire. You're going to know its density. You can calculate its volume. Right? You'll also want to then be able to find what's the radius of that wire. So volume equals the length times pi times the radius squared. And if I want to solve for this radius, then I'm going to divide both sides by the length and by pi, so that it cancels out here on my right side. And so volume divided by length and pi is the radius squared. Well, we want just the radius, so I want to take the square root of both sides. And so in the end, that tells me that this radius is the volume divided by the length times pi, but the square root of all of that. Okay, so that should help you get the volume of the wire and to calculate its radius so that you can continue doing the other parts of that lab experiment. Now, at the end of that lab, you have 5 problems, and these examples are going to help with those particular problems. All right, but what I want to point out first before we jump into all of these is that when you're talking about atoms and molecules, we a lot of times use Avogadro's number. Okay? And Avogadro's number is a very large number, 6.022 times 10 to the 23rd power. Okay, it's referred to as being 1 mole. It's like counting, you count donuts by the dozen. When you count molecules and atoms, you count them by the mole, which is equivalent to, whereas a dozen is 12, a mole is a really large number, 6.022 10 to the 23rd. Okay, well, this is also equivalent to the mass of an element. Okay, when you look at a periodic table, like in these examples, we're going to be using the ones I have highlighted here. But gold, for example, gold has a mass right here of 197. This is its average atomic mass, 197.0. Well, that is its mass. If you had that many grams of gold, that would be equivalent to 1 mole of gold. Okay, so 1 mole equals Avogadro's number. That also equals the mass of an element measured in grams. Okay, we're going to make use of these as we do these examples. They're really conversions is what they are. So this very first one says if we have 42.5 grams of silver, how many moles will that be? All right, so if I start with 42.5 grams of silver as Ag, and I want to know how many moles of silver, I wrote symbol for gold there, how many moles of silver are we going to have? Okay, well, I need these grams of silver to cancel out. So when I go to my periodic table, I'm going to use this one. It's got a little bit more detail to it, a few more decimal places. So when I see silver right here, 107.86 82. Okay, that's the number of grams of silver per mole. Okay, if you use a different one, here, if you wanted to go use this and do 107.9, that's completely fine as well. Okay, you're just not going to have as many decimal places, but it's not going to make enough difference, to worry about. Okay, so let's just say we use 107.9. I'll use this one where everything's highlighted, make it a little easier for you to see, hopefully, in the video. All right, so what this means is we're going to have grams of silver divided by grams of silver. That's going to cancel out. So in my calculator, I'm going to take 42.5 times 1, which I don't need to do. So I need to divide this by 107.9. And that tells me that this is equivalent to 0.394, we'll go 3 decimals here, 0.394 moles of silver. Right? We need almost 108 grams to have a whole mole of silver. We only had 42, so we had less than 1 mole. All right, this next one. If we had 42.5 grams this time of gold, how many atoms would that represent? Okay, so this time we're using gold, but 42.5 grams of gold. We want to know how many atoms that's equivalent to. Well, when we look over here at gold, okay, gold we saw earlier, 197 grams of gold in 1 mole. All right, so I put that 197 grams of gold down here so that it's going to cancel out in just a moment. But that's equivalent to 1 mole, which is equivalent to Avogadro's number of gold atoms. So I'm going to put right here on top 6.022 times 10 to the 23rd atoms. Okay, that many gold atoms equals 1 mole equals 197 grams. So 197 is going to cancel. All right, so I got more work to do this time. 42.5 times 6.022 times 10 to the 23rd divided by 1.97. I have a separate video on scientific notation. I'll link that in the description below as well. All right, so this gives me 1.299. I'm going to round that up to 1.30. But then out here at the edge, I notice this is times 10 to the 23rd power. You should have a very large number of atoms. You shouldn't be calculating small numbers of atoms here. All right, so 1.30, 10 to the 23rd atoms of gold, or gold atoms. Third example, what is the mass of 2.5 moles of titanium? Titanium symbol is Ti. So if I have 2.50 moles of titanium, I want those moles to cancel out. So if I had just 1 mole of titanium, then titanium would have a mass of 47.9 grams. So 47.9 grams of titanium is equivalent to 1 mole. Okay, the moles are going to cancel out. So I need to do with my calculator 2.5 times 47.9. And I would have, I'm going to round this, this would be 120 grams of titanium. All right, so I took the number of moles and I multiplied it by the molar mass for that element. Next example, how many atoms of iron are present in 3.4 moles of iron? Okay, so this time we want to convert moles to atoms. 3.40 moles of iron times, all right, I need my moles to cancel out. So if I had 1 mole of iron, Okay, 1 mole of any element is Avogadro's number of those atoms. So it doesn't matter if this is iron or nickel or silver or whatever it is, 1 mole is always Avogadro's number of atoms. Those moles are going to cancel out. And so with my calculator, I'm going to do 3.4 times 6.022 times 10 to the 23rd power. And again, I'm going to get a large number of atoms here. I get 2.05 times 10 to the 24th power of iron atoms. Right? So large number of atoms again. All right. And then this final example, how many moles of nickel are present if we have this many atoms of nickel? So if I have 1.54 times 10 to the 24 atoms of nickel, how many moles is that? Okay, so again, I'm trying to this time figure out how many moles I have present. But 1 mole of nickel or aluminum or anything is Avogadro's number of those atoms. So 6.022 times 10 to the 23rd atoms is equivalent to 1 mole. So the atoms are going to cancel out. And so this time on my calculator, I want to do 1.54 times 10 to the 24th power divided by Avogadro's number, 6.022, 10 to the 23rd power. And now, because I'm calculating moles, I should get a smaller answer. So 2.557, that's going to round to 2.56 moles of nickel. All right, but again, these 5 examples should help you with questions 1 through 5 on the atomic radius lab. So I hope these example problems have been helpful to you. If you need more help, feel free to reach out to me. Again, I'll put links to the documents down in the description below. But y'all have a great day.